Next up, some equations that involve rational expressions. Here I have x over 3 plus 1/2 is equal to negative 1/2. I want to solve this equation for x. I could simply solve it using the fractions right here, but instead what I'm going to do is find a least common denominator for all the denominators. The least common denominator, remember, has the property that all denominators divide it evenly. So if I find the least common denominator for all these fractions and multiply each term on both sides by that least common denominator, all of them should divide into it, and I should be left with an equation that doesn't involve fractions. So the least common denominator for 3 and 2 is the number 6. So I'll multiply this side of the equation by 6, and then I'll do the same thing to the other side of the equation. So now when I multiply 6 times x over 3 by the distributive property, I have this, plus 6 times 1/2 is equal to negative 1/2 times 6. 6 times x divided by 3, remember this is 6 over 1. 3 divides into 6 twice, times x is 2x. Plus 6 times 1/2 is 3. Negative 1/2 times 6 is going to be negative 3. I add negative 3 to both sides. I end up with 2x is equal to negative 6. Divide both sides by 2, and I have x is equal to negative 3. So that's my solution, x equal negative 3. And you see this equation right here is the equation I obtained by multiplying both sides of my original equation by the least common denominator. Notice that it's very simple to solve. So what I'm doing with these problems right here is clearing the equations of fractions. Notice if I substitute x equal negative 3 back into my original equation, I have negative 1 plus 1/2 is negative 1/2. So I get a true statement. Let's try another problem. How about this equation right here? I look for the least common denominator for y, 2, and 4. That should be 4y. So I'll multiply this side by 4y, and I'll multiply this side by 4y. I multiply 4y times 1 over y, and the result is 4. Minus 4y times 1/2 will be 2y, equal negative 1/4 times 4y should be negative y. So there I've done two steps at once. I've found the least common denominator and multiplied both sides by it, but I didn't actually show that distributive property. I'm using the distributive property and simplifying at the same time. So now let's solve this for y by adding 2y to both sides. I end up with 4 is equal to y. Well, that's kind of nice. That simplifies real quickly. Is that right? Add 2y to both sides. I get negative y plus 2y is 1y. And then on this side I have left just 4. That's right. So 1 over 4, 1/4 minus 1/2 will be negative 1/4. That's correct. So I multiply both sides by the least common denominator. It clears the equation of fractions, and the equation I end up with then is a lot easier to solve. Let's take this a little further. This problem right here, I look for the least common denominator for all three fractions, and remember 1 is the same as the fraction 1 over 1. So the least common denominator for 1, x, and x squared is simply x squared. So I multiply the left side by x squared and the right side by x squared. X squared times 1 is x squared. Subtract x squared times 8 over x. That x divides out with one of those two factors of x, and I'm left with 8x. 15 over x squared times x squared. The x squared divide out, and I have minus 15. So look what I have here, a quadratic equation. I have x squared minus 8x equals negative 15. Need to put it in standard form, factor it, and see what I get for solutions. So x squared minus 8x plus 15 is equal to 0. That factors into x minus 3 times x minus 5 is equal to 0. I set this factor equal to 0, and I get x is equal to 3. I set this factor equal to 0, and I get x is equal to 5. So two solutions for that equation, and I look back to see what I multiplied both sides by. It's x squared. Neither of these two numbers right here make what I multiplied both sides by equal to 0, so they're good solutions. Let's try one last problem. Let's see. I have this rational expression plus this one is equal to this one. This forms an equation. Let's see if we can find a solution. I'm going to start by factoring this denominator, x plus 2, x minus 2, plus 3 over x plus 2 is equal to 1 over x minus 2. So if I look at this denominator, this one, and this one, I see that the least common denominator is x plus 2 times x minus 2. So I'm going to multiply this side by that, and then this side also. Now, if x turns out to be negative 2 or 2, I can't use them because I've multiplied both sides by 0. So I take this product right here, multiply times this first rational expression, and the result is just 8. Both of those factors divide out with both of those. Plus, this product right here times this second rational expression, the x plus 2's divide out, and I have 3 times x minus 2 left. Equal this times that product, the x minus 2's divide out, and what I have left is x plus 2. So let's see if we can solve this real quickly. 8 plus 3x minus 6 is equal to x plus 2. This is 3x plus 2 is equal to x plus 2. I'll add negative x to both sides. I'll end up with 2x. I'll add negative 2 to both sides, and I'll end up with 0. So I end up with one solution, x is equal to 0. So when x is equal to 0, I get a solution to this equation right here. So I have to check that x equals 0 back in my original equation and be sure that I don't have any undefined terms. The only way my original equation would have any undefined terms would be if x came out to be negative 2 or 2. In this case it didn't. X came out to be 0, so I don't get any extraneous solutions. Same idea in all of these problems. Factor all your denominators, then build the least common denominator from those factors, multiply both sides of the equation by that expression, and you'll be left with an equivalent equation that does not contain any fractions.